right, so here's a function. It's a cubic function. We're told it's increasing from -infinity to 1 and from 3 to infinity, and then it's decreasing from -1 to 3. So if I think about that, I've basically been told that I have a cubic that's going from increasing to decreasing to increasing. So essentially what I've been told, increasing to decreasing up until, that's increasing until -1, and then I start increasing again at 3. Basically, I've been told the x coordinates of my stationary point. Find where the graph is concave up and concave down. Well, I'm concave down here, concave up here. I want to figure out the x value in between -1 and 3, where that switch happens. So I want to know this point. I'm going to take my first derivative. It's going to be 3x squared minus 6x minus 9. My second derivative is going to be 6x minus 6. So I know that this change is happening where the second derivative is 0. So at x equals 1, the second derivative is 0. So that means that this point here is 1. So I could say that I'm concave down on the interval from -infinity until 1. I'm concave up otherwise. So that's from 1 to +infinity. And find where it's concave up, concave down. Sketch, label my points of inflection. So here is my point of inflection. I'm going to call it POI. So the point of inflection is going to have x coordinate of 1. When I plug 1 into the original, I'm going to have 28 minus 12 is going to be 16. So this point of inflection is going to be at 116. I've graphed this function already over here. So let's test that out. 116. And there's my point of inflection. That appears to be true. The other thing I could do is come back and call this f of x. And I could say y equals f double prime of 1. And sure enough, that gives me 0. So my second derivative here is 0.